All right, looks like our attendees are leveling off, so we will go ahead and get started. My name is Samantha Martin. I am the Communications Manager at Cleveland Water Alliance, and I'd like to welcome you to our webinar in partner with ALTRA Solutions. And the theme of this webinar is how to address lead in our drinking water. And we'll go ahead and introduce the panelists, but I'd like to let you know that this webinar will be recorded. It will be sent out to all attendees and registrants, whether you're tuning in live or not. If you signed up, you'll get a copy of this recording on our YouTube when it's live, and you're welcome to share it with your network and with your coworkers and anyone who isn't able to attend. I will introduce our first panelist, Ben Côté, President of Sanexen Water, Inc. And we have Tim Cansler, founder and chief strategist of Cansler Consulting. And I'd like both of you, before we get started, to just give a brief overview of your experience in this field and what brings you here to talk about this today. We'll start with you, Ben.
Good, thanks, Samantha. Yes, I'm Ben Côté. I am the president of Sanexen Water. Been involved in all aspects of water distribution for well over 20 years now. I participated in the development of trenchless technologies to address drinking water distribution lines, drinking water mains, and more recently with lead service lines. So at Sanexen, what we do basically is that not only are we developers and manufacturers of very innovative products to address issues in the water infrastructure, but we are also contractors and installers of our own technologies. So for the better part of 20 years, I've been dealing with water mains and drinking water, and now I'm excited to talk to you about what's come up as far as innovation for the removal of lead service lines.
Thanks, Ben. And Tim, go ahead and give yourself a quick introduction and tell us what brings you here today.
Well, thank you, Samantha, and thank you to the Cleveland Water Alliance for hosting this. I guess what brings me here today is coupling up with the innovative folks at Sanexen Water, and they are true innovators in their technology. I think, as you will see today, really intrigued me in helping them to get the word out about the technology and to also educate lawmakers on the technology, lawmakers and the regulatory community. I've been doing this for more than 20 years now, and I've worked a little bit on the House side, both in district offices and on Capitol Hill, and I've worked in regulatory agencies in Washington. So, I just wanted to bring that experience to help this issue along, and somewhat kind of like the Cleveland Water Alliance is doing. I really cherish your all's goals to bring forward technology where it's needed, and we just can't rely on the old way of doing things anymore. We have to be creative, we have to be innovative, and you know what? Then we have to adapt to them. So I appreciate the opportunity to be here.
Thanks so much, Tim and Ben. Before we get started into the questions for our attendees here, if you have any questions as our panelists are talking, go ahead and use the Q&A function at the bottom of your screen, and we'll save time at the end for questions. I'd also like to invite you right now to use the chat function. If you just want to tell us what industry you're coming from, what your background is, just tell us what brings you or what interests you and brings you to this discussion today. That way we can make sure we tailor our answers and our questions around that. So if you just want to throw that in the chat, what industry you're in, or what brings you here and why you're interested in this topic. But let's go ahead and get started with the questions. Tim, why don't you start by bringing us up to date on the EPA's revisions of the lead and copper rule and where they stand today?
Well, I think everybody on this call and our astute audience knows that for the past few years, the Environmental Protection Agency has been promulgating major revisions to the National Primary Drinking Water Regulations, which are better known as the Lead and Copper Rule. And previously, the Trump administration published a revised final rule in the Federal Register on January the 15th. And they made the effective date of these revisions on March the 16th. And some of the revisions in the version of the published LCR included a retention of the current lead action level of 15 parts per billion. It required all water systems to prepare and update lead service line inventories. There were provisions in there for water systems serving over 50,000 people that they must post information about lead service line inventories on a website that's accessible to the public. EPA also introduced a requirement to find and fix sources of lead in any individual home where tests demonstrated that the lead levels exceeded 15 parts per billion. And it requires water systems to replace at least 3% of lead service lines every year when 10% sampling results are over 15 parts per billion. And interestingly, while the old rule required water systems to replace 7% at an annual rate, EPA at that time was arguing that, hey, look, over the last 30 years, really the effective rate was 1%. So the 3% that we're putting in the rule is actually an improvement. The rule also establishes a new contaminant threshold of 10 parts per billion. And when that's exceeded, it requires water systems to do more rapid implementation, corrosion control treatments, and lead service mitigation programs. It also requires water systems to follow a new tap sampling procedure, and it's supposed to help better locate the elevated lead levels in drinking water. And it also requires a fifth liter sample. And then it requires water systems to test for lead in drinking water at elementary schools and child care facilities. So 5 days later, on January the 20th, when the new administration, President Biden is inaugurated, Ron Klain, President Biden's chief of staff, he issued a memorandum to all the heads of departments and agencies, basically saying, look, we're going to freeze all the regulations until we can take a look at them. And interestingly, in this process, on March the 1st, 9 states attorneys general filed a petition against the EPA and the U.S. Court of Appeals here in the District of Columbia. And they stated that certain aspects of the rule are unlawful and they have to be vacated. And of particular interest, the AGs did warn that the reduction proposed in the rate of lead service line replacement from 7 to 3%, it might violate an anti-backsliding provision in the Safe Drinking Water Act. And I think pertinent to this conversation today is something else that the AGs commented on in urging the EPA to reduce the action level for replacing the pipes below the 15 parts per billion actionable level. And they cited, given significant advancements in lead detection and service line replacement techniques. So EPA has now issued 2 extensions of both the effective date of the final rule revisions and the compliance dates. And currently the effective date is now December the 16th of this year. And the compliance date is almost 3 years later, October the 16th of 2024. EPA is also, they're just now conducting listening sessions with all impacted stakeholders. And they're now beginning, I think, more in-depth roundtable engagements with stakeholders on the rule. One of the things that I want to mention that I think is important to the conversation is, when it comes to EPA implementation of the lead and copper rule, the budget is important. And in Washington, we're right in the middle of the annual budget and appropriation cycle. So in late May, President Biden sent his annual budget for fiscal year 2022 to Congress. And in that budget, interestingly, he included a 21.3% increase for EPA. And during the release of the budget, President Biden made an interesting statement acknowledging EPA staff losses and how it impacts their analytical capability and ability to advance research and invest in infrastructure. And I think all of you all know that in Washington, we're heavily involved in an infrastructure debate right now. But the 2022 budget proposal included an increase of over 1,000 full-time equivalents for EPA. And just to give you some comparison levels, in 2008, EPA employed a total of 18,000 people, and today it's right about 14,000. And in a congressional hearing 2 weeks ago, Administrator Reagan mentioned this in a hearing. He said that nearly half of EPA's total staff are going to be eligible for retirement in 5 years. And Samantha, if I can get the technology to work here, I wanted to show our audience this particular graph, if I did that correctly, and everyone can see that.
Yes, you did, Tim.
This chart is showing the EPA Office of Research and Development full-time equivalent for fiscal years 2005 through 2021. And as you can see there, highlighted, the decline from fiscal year 2012 to 2020, that's 22% in a very important office within EPA. So, it does give rise to concern about, as we go forward, the future capabilities of EPA in implementing the lead and copper.
That's really helpful. We've gotten a lot of responses in the chats. We've got a lot of innovators here. We've got a lot of folks who are just friends of CWA and who are generally interested in this topic. We've got consultants. We've got folks who are working on mitigation and replacement strategies. So we've got folks across the gambit, and we're probably going to get some technical questions in. We've already gotten a couple in here. But next question I will pose to Ben. So Ben, the lead pipelines are still serving drinking water. I mean, we all know about, what's happened in Flint. And to an estimated 6 to 10 million households are being fed drinking water across the US via lead pipes. So that's a lot of lead service lines still in operation after Congress banned lead decades ago. And now we've learned, so much more about the impact and harmful effects of lead, especially to marginalized communities. This plays a role in economic, environmental justice. So Tim mentioned the possible fiscal and resource challenges at the EPA and how that might impact EPA's future implementation of the rules. So water systems around the country are also experiencing fiscal challenges and workforce challenges. And Sanexen is an innovative company. So with your experience, can you talk about innovation and construction methods and how they might help water systems and the EPA in the future?
Yes, of course. So here's a big problem. We've got 6 to 10 million lead service lines to address within the next decade or so, hopefully. And anytime that you're doing construction work or planning, you need to understand that the water systems, they need to take into consideration the timing, the seasonality of the works in some areas, and how the work is going to get done between replacing lead service lines. How old is my original water main? Do I need to address that water main at the same time? So there's a lot of sequencing going on. And at the same time, it's costly. You're going to have to spend some money to do this and to replace this. And, utilities have been using most of the time construction methods that were used 50 to 75 years ago. Basically, when we did put these lead service lines in place or any other type of utility, you built those utilities 50 to 70 years ago and using 50-year-old construction methods. It makes sense. But now we need to look into different ways, because these traditional construction methods are going to be timely, going to take a lot of time. It requires heavy equipment. It requires a lot of the time digging, because this is buried infrastructure. And these methods to replace lead service lines specifically will range anywhere between digging up a trench and replacing that lead service line to now some newer ways of doing it, pulling the lead pipe across the ground. Hopefully the lead pipe is not going to break, because it's a very soft metal. And all these require, again, time, heavy machinery, and have a large impact on the community and on the homeowner anytime this construction is happening. There's got to be a better way of doing things. And that's what we're focusing on, is that there's got to be ways of doing and replacing those lead service lines in a much faster way, easier, less disturbance to the homeowner in the community. And this is where innovation plays a big role. And mostly when you look at innovating new construction practices, you got to take into consideration, you want to do this quickly, you want to save time, you want to find a method that's going to be saving money, obviously, less costly, and most importantly, reducing the impact in the community and the homeowner. So these are the focus that we're looking at when we're developing, and as a contractor, developing ways of doing more, different ways of doing construction. Now, keeping this in mind, the water industry, they're attempting to find, they've got difficult challenge to face. There's safety issues. There's some other utilities on the ground nowadays, not just the lead pipe that runs between the water main and your house. They have to look at budget. They have to look at costs. I mean, they don't have a whole lot of money to spend, and they need to spend it in a very smart way. And then they need to look at operational efficiencies. When you're talking about 6 million lead service lines to replace, you gotta find a way where it's going to be efficient. You're going to have an efficient flow going, replacing those lead service lines, from street to street and from neighborhood to neighborhood. So what we've been focusing at Sanexen for 20 years now, is basically on trenchless technologies. We started off with trenchless technologies to renew water mains from the inside with a lot less impact on the community. And recently we've looked at a trenchless technology to replace a lead service line internally with a brand new pipe, as opposed to digging up the whole neighborhood. And this is how we've come up to situations and technology where we can address these concerns that the water utilities have had over the years. So if you'll let me, I want to show you a couple of slides that show some of the trenchless technologies being used out there. And of course, I want to show you what we've come up with as a trenchless solution. So bear with me. I will try to show you this so that everyone can see and understand. So one of the major things, and one of the most common ways to deal with lead service lines, typically nowadays, and a lot of construction companies will use this, is basically pulling. So we want to pulling the lead service line out of the ground. By using sometimes heavy equipment. You'll be digging a hole either at the water main or even at the curb stop, and through that hole you'll be using heavy winches and pulling that lead pipe out of the ground. And this is what you can see in the pictures right there.
I'm going to go ahead and make that a little bit bigger. I think we're seeing the presenter view.
Oh, okay.
Exit out of that, just so the photos show up a little bit bigger there.
Does that work better now?
I'm still seeing, if you want to exit out of that view.
Yeah. You want to exit out of the view for me, Samantha, please?
Yeah, that's no problem. Just restart that. All right, go ahead and retry that.
Yeah. Is that better?
Better, thank you.
Of course. Another way of pulling is that now recently different companies have come up with equipment that are specialized in pulling lead service lines out of the ground. And you can see a piece of equipment there that is used sometimes. Now, pulling has disadvantages, obviously, and I mentioned one earlier, is the fact that lead is a very soft metal. So by pulling the lead pipe, sometimes the lead pipe will completely break, and then you still have to dig it up and remove it. Another method that we've used to some degree is molding. So pneumatic molding or hydraulic molding. And molding basically involves pushing a rod inside the ground and creating a small tunnel, in which tunnel you'll be pulling in a brand new pipe, either plastic pipe most of the time or copper pipe. in some areas where it's specified. Big disadvantages of molding is that you can't really control the mold all the time. So if it hits a rock, it's going to go in a different direction. And especially if you have other utilities between the point of entry and the area you want to replace the lead pipe, then you could definitely hit those utilities. You certainly do not want to hit a gas line or communication cables, for instance. So molding is a good method, a good trenchless method, but it has a lot of limitations that we need to deal with. So what we've come up in our Ultra LED solution basically is that we're rebuilding a brand new water pipe inside the existing lead pipe. And the way it's done is it uses very small equipment, compact equipment. We will have an access point most of the time at the curb stop. And from the curb stop, we will go directly into the house. So we will have removed the meter inside the house, and we'll be pulling a small piece of plastic pipe of PET, polyethylene terephthalate, inside the existing lead service line. And we'll inflate that PET pipe to the size of the existing lead service line. Now, all of that can be done quickly. It has very little disturbance for the homeowner. It has very little disturbance for the community. And we, when working efficiently with a couple of crews, you can certainly do quite a few lead service lines in a day. So this is the method that we've come up with, and we've started installing in different areas, and it's working out very, very nicely. So we'll be pulling, on average, we'll be pulling roughly 50 to 100 feet into an existing lead service lines, but we can certainly pull it up to 300 feet, which would cover most of lead service lines, that go into a house. So just to give you an idea of how it, some pictures. Completely on the left is the curb stop excavation. So very small hole that needs to be dug up. We take out the curb stop, and this becomes our access point. Once inside the house, we're basically pulling the PET pipe inside the existing one, and then we'll reconnect directly inside the house once inflated. So it's a very simple installation. A lot of plumbers can actually do this. And I mentioned that we use PET. PET is basically the exact same polymer that is being used for water bottles. PET has also been used in the medical industry, for instance, to make different types of implants that are made with polyethylene terephthalate. So it's very stable. It's a very stable material. It will resist to water that contains a little bit of chlorine, because we know drinking water does contain a little bit of chlorine. It's extremely resistant to other types of products, and resistant to pressure, obviously. And with just one small pull, we can expand it up to 250%, which is a fair amount. And this will still keep holding pressure. So I'll just stop sharing here. Excuse me. So you can see that, just by using a little bit of innovation, we come up with ways of replacing lead service lines that are efficient, less costly, and of course, less disturbance. Good point to mention is that PET is a pressure pipe, and has a life expectancy of well over 50 years. So in areas where you're dealing with old infrastructure, that could be a great ideal situation that you could use PET in. So trenchless technologies, obviously, one of the other advantages is that they are very climate friendly. So anytime you're using trenchless technology, you're reducing the amount of greenhouse gas emissions that you're emitting into the atmosphere. And you need to know that within the new revised lead and copper rule, I think Tim mentioned it, but there is a request to survey all of the lead service lines, so where they are, and identify where they are. So take, for example, in a situation where you'd be taking out the lead from the ground, Then you spent this energy and money to find out where they are. Now you're taking the lead out of the ground. You're transporting it to hopefully a recycling facility. If not, you're transporting it to a disposal facility. So you're emitting greenhouse gases during the transportation. Lead is a very heavy metal. And during the recycling process, most of the time the lead pipe will be melted into a lead acid battery electrode, for instance. Again, this is a process that emits a lot of greenhouse gas emissions. So utilities that are becoming now more sensitive to the environment would certainly appreciate the fact that we can use lead, trenchless technologies to deal with that. Final point that I wanted to bring up is the impact for the homeowner. Because for us, being at the start an environmental company and a services company, we certainly take the environment seriously, and we want to find ways to do construction in a different way so it doesn't impact the environment as well. But we also have in mind the homeowner. And anytime that you'll be doing a traditional lead replacement method, the homeowner is going to be impacted. One, they're going to get their landscaping pretty much crashed. They're going to have to redo their landscaping. Secondly, when you're pulling, for instance, a new pipe, you're going to be creating an open hole into their foundation wall or through their concrete slab in the basement, and the homeowner is left with that. And he needs to deal with that. Eventually, it could be a situation where you would get water infiltration over time. The other thing that concerns me, and when you think about the homeowner, is that using traditional methods, we're looking at decades and decades of construction work. I certainly do not want to be the homeowner that gets his lead service line replaced 25 years down the road, knowing that my water is contaminated with lead. So that's where innovation comes and helps, where we can increase the speed of replacement, not costing more money, just doing it faster, more efficiently, and with respect to the homeowner at the same time.
Yeah, absolutely. And great questions, everyone. Keep them coming in. We will save plenty of time for them shortly here. So Tim, Ben mentioned all of these innovations, and innovations require money. So we know that Congress is debating a huge infrastructure package that would include funding for drinking water infrastructure. Can you tell us about some of the legislative proposals Congress is working on for this infrastructure package that is directed to drinking water?
Yeah, sure. A couple of pieces of legislation that we're watching and interested in. Over in the U.S. Senate, they have passed S 914, which is the Drinking Water and Wastewater Infrastructure Act of 2021. They passed that by a vote of 89-2. 89-2. I mean, it's just overwhelming the support that water infrastructure has in the Senate. And this bill, it authorizes a total of $35 billion over 5 years for fiscal years 2022, which starts this October and goes throughout fiscal year 2026. 42% of this total, that's $14.65 billion, is directed to the State Revolving Loan Fund. And they ramped that up, starting out with like $2.4 billion, which is double what it is right now. The appropriators last year in Congress adopted 1.126, I believe, for the State Drinking Water Fund. So this legislation instantly doubles that. Then they ramp it up to 2.75 billion in 2023, 3 billion in 2024, and then top it off at 3.25 billion for each fiscal year 25 and 26. One of the interesting components in this legislation, I think that is pertinent to this conversation, is the Senate creates a $10 million annual grant program for water systems that serve 100,000 or fewer people. And they just simply have to plan to identify or have already identified opportunities to employ new or emerging proven technologies. And that includes technologies that address things like cybersecurity, They enhance treatment, monitoring, affordability, efficiency, or the safety of drinking water. There's also about 35 million in there for technical assistance, 50 million in this legislation for natural hazards, cybersecurity, and extreme weather. There's also 50 million each year for water systems operational sustainability that improves the operation of small systems. Over in the U.S. House, just last week on Wednesday, the U.S. House Energy and Commerce Subcommittee on Environment and Climate Change marked up H.R. 3291. This is legislation introduced by the subcommittee chairman, Mr. Tonko of New York. And this administration pretty well matches the American Jobs Plan that was introduced by the Biden administration, and it invests about $105 billion over 10 years for water systems. 53 billion of this total is going to be directed to the Drinking Water State Revolving Fund, and that's broken down into tranches of $4 billion, a little over $4 billion for FY 2022, 4.8 billion in FY 2023, and 5.5 billion for each year in FY 2024 through 2031. It's a substantial amount of money that the House is putting in this legislation. States are not required to contribute to the state loan fund, and there's no cost to the private homeowner. There's also $45 billion to replace every lead service line. This, of course, was in the American Jobs Plan that the Biden administration put out. And that $45 billion is spread out over a 10-year period. And there's a total of $5 billion. I know this conversation is not about PFAS, but we're all learning about PFAS relatively quickly. But they put $5 billion in this bill to mitigate PFAS contamination over 10 years. There's also $4 billion in emergency relief programs that will help forgiveness for utility customers that are facing debts or unpaid fees since the pandemic began back in March the 1st. I want to show our audience another chart that I'll think it'll give you a good idea of the current levels of funding that Congress is considering. Wrong chart. Bear with me. Okay. Just grabbed the wrong chart. Hang on.
And we can, if you don't have it handy, we can move on to some questions and give you a little bit of time to pull that up if you need a few moments.
Okay, there it is. Sorry about that. But and I'll be real quick about this. I mean, you know, the levels there over on the right, you see the orange line. Actually, let me start with the blue line. That's just what Congress has appropriated over the years, going back to 1997 for the Drinking Water State Revolving Fund. The orange line is what Congress has enacted in the America's Water Infrastructure Act in 2018. And then on the right side, the blue lines is the Senate proposal, S914, and the two red lines are the House proposal in HR 3291. And as you can see, we haven't seen this level of funding since the American Recovery Act after the Great Recession of 2008. So I wanted to show you this because I think it's really important to show just the level of interest in Congress that's coming. And I don't want to get too far ahead of myself, but I'm pretty bullish in this infrastructure package passing Congress.
That's a really helpful visual, Tim. Thank you. And surprising, honestly. So we'll get started on some of the audience questions, and we'll start with Ben. So, we learned that there's no cost, dollar amount cost to the homeowner, but time is also a cost in terms of just disruption. So can you talk about the relative installation speed and how that relates to the other mitigation options?
Yes, that's a good question. So when you look at there's two scenarios to look at. So there's the what I call the one-off scenario, basically where you're going to one specific address, one house, and you're doing the lead service line replacement. So when you look at this scenario specifically, one, you can replace the lead service line within the same day using a trenchless technology. You would be digging up a small access hole during in the morning. You would actually shut off the water to the house for approximately 2.5 hours, and then within 2.5 hours, you've basically put in a new pipe instead of the lead pipe going to the house, and then you would spend a little bit of time just backfilling the small excavation you did. So all of that can be done in one day when you're looking at a one-off, a situation where you only have one place to do. Now, in a lot of areas, some utilities now are starting to pull out some contracts where you have several houses to do. Like we've worked on contracts where we have as much as 1,500 lead service lines to replace, and most of the times, it's very rarely if you go into a street and you have a lead service line at one house, pretty much all the houses in that street built during the same era would have the lead service line. So when you have a system going, where you have a production going, replacing a lead service line can be extremely quick. We can do 5 to 6 per day with just 2 crews and just excavating and having a plumber going behind you. So you work as a train. You have an excavator in front of you digging up the access points. We pull in the polyethylene pipe inside the lead service pipe, and then you have a plumber reconnecting everything and backfilling. So it goes very quickly. Because you can get that productivity going, the cost it will range depending on where we are in the situation. If we're digging in the sidewalk or digging on the boulevard or just digging on someone's property, the cost will range, but typically will be easily 25 to 40% lower costs using trenchless technology than you would if you were doing just typical dig and replace type of method.
And where does cost compare in that as well? That was another question that came in.
Where what compares? Sorry?
Cost. How does cost compare of the different mitigation?
Well, again, it varies quite a bit. In some areas of the country, you will be replacing a lead service line completely with traditional construction methods for anywhere between $500 to $7,500 per line. And in other parts of the country, you can do the same type of work for probably less than $4,500 or $4,000 per line. So it varies quite a bit. So when you're using a trenchless technology, that's where the savings come. So when you're spending, let's say, $6,000 to do a lead service line replacement, then we would probably do the same type of lead service line replacement for around $4,000 to $4,500. Taking everything else considered being equal. It will vary quite a bit, but most of the time, these are roughly the price ranges that we see across the country. Another thing that needs to be considered, and Tim, maybe you could tell us a little bit what the revised lead and copper rule says about that, but on a lot of these contracts that we execute, the contracts are for the public side replacement only, not the private side. So again, there you go, going into all this trouble and spending money replacing a lead pipe from the water main to the property limit, and the lead pipe stays on the private side and the homeowner has to deal with it at some point. To me, that does not make sense. I completely understand why utilities do it. So I'm curious to see, hopefully, that and I don't know, maybe Tim, you can add to that, but hopefully the revised rule will impose on utilities to deal with the lead service line from the water main to the house completely, and not leave the homeowner with just half of a pipe replaced.
Yeah, I would add to that, Ben. I think it's an excellent point. I would first start by acknowledging that the lead and copper rule does require water systems to distribute public education materials to homeowners. And even when they don't even know what type of lead service line they have, there's still that type of engagement going on. There's also acknowledgement of the water system actually making contact with the homeowner. Even though there might be what they call a documented refusal of the homeowner just refusing outright to replace their side. It does contain provisions about those types of situations, but it just mainly focuses on the contact that the water system makes. It doesn't say anything else, and it doesn't add to the replacement rate. But largely, I think this is one component that has been totally absent from the whole conversation and the process is homeowner choice. And the trenchless technologies that you've just described, Ben, that's a choice. And I do know also that the Safe Drinking Water Act, under the provisions of contact of notice, it mandates that water systems provide the homeowner with readily understandable explanations of reasonably available methods to mitigate the lead service line. So, I think it's incumbent that homeowners know about this technology. It's available, it's certified, it's safe, it checks a lot of boxes, and the law stipulates that they've got to know about it.
Yeah, thank you both. A few more questions here. For Ben, are there multiple size PET tubes for differing applications? Can the PET installation be used for large diameter applications other than home services?
Again, excellent question. Yes, there are several sizes, different sizes of the PET tube that we use, depending on the service line size. So we'll line anywhere between 1/2 inch in diameter to 2 inches in diameter. So we're really concentrating on the smaller diameter pipes, and this is what we find most often in the distribution of water to different buildings. If we go to higher sizes than that, so 4 inches and up and 6 inches and up, sometimes you'll have connections between an apartment building and the water main that's going to be a 6 inch in diameter. Then yes, trenchless technologies certainly exist to do that. We use a different type of material. We use for those of you that are familiar with cured in place pipe, we use a cured in place pipe technology where we rebuild the water main, the 4 inch pipe from within. So depending on the size, we'll use different technology. But overall, as it pertains to lead service line replacements and the PET tube, anywhere between 1/2 inch to 2 inches in diameter, and we have several sizes of tubes that we'll use depending on the situation.
And along those lines, another question that came in, any restrictions on this, bends, et cetera? So other than diameter, are there any other restrictions?
Very good. So we can negotiate bends. We'll negotiate bends up to 45 degrees. So over 45 degrees is going to be difficult. So a 90-degree bend we would probably try to take out before we put a PET pipe in it. And then obviously because of the size of the pipe that we are replacing, we cannot have access to any type of connection from inside the pipe. So if you run into a T connection, at some point we would have to remove the T and then put in the PET pipe inside and then reconnect that T afterwards. So as far as bends, up to 45, And then any type of T connection or bends higher than 45, we would have to remove.
And another question here. Ben, how is that lead service line replaced from the curb stop to the water main?
It's replaced pretty much in the same way. So in instances where we do from the water main right into the house, we will have, obviously, we'll have to do an excavation at the water main where the house connection is done. We will we'll remove the corporation stop and then line from the water main directly into the house, and we'll have another small excavation at the curb stop. So we can line it, we could put it in one shot from the water main right directly into the house with two small excavations, one on the water main and one on the curb stop. In instances where we would be aligning the water main at the same time during the same contract, we can actually save one of the pits, so the pit on the water main, because we've developed tools that allow us to pull a PET pipe from inside the water main directly into the house. But those are only instances where we're actually lining the water main at the same time as we're replacing lead service lines, which is fair, you know, it's becoming fairly common with some utilities.
Another question that just came in, does the curb stop get replaced in the course of the relining operation?
Totally optional. If the curb stop is still operable, there's no reason to replace it. We would just disconnect it, do what we have to do, and reconnect the same curb stop. It's very, very common that a 50-year-old or 70-year-old curb stop will not function properly. So in those situations, we'll be putting in a brand new curb stop.
Yeah, really good questions coming in. Thanks, everyone. Another question that I will answer from the perspective of CWA, and then please, Tim and Ben, jump in here if I'm wrong. So the question is, what is the best available technology for detecting lead service lines without excavation? And it is my understanding that that doesn't currently exist. So we as CWA actually put out an open innovation challenge earlier this year, partnering with organizations like Cleveland Water to build a pipe farm for innovators to come. And they proposals came in recently, we reviewed, and we have several potential viable options that are going to come in and actually test that technology. But as far as I'm aware, it doesn't really exist at this point. Ben, Tim?
Well, you're right, Sam. I don't know of any real true way of detecting it without seeing it and digging it up. But two things. So one, obviously, tap water analysis will give you some indication. But again, if you do find lead in your tap water, it could mean that you have a lead service line. It could mean that you have lead in your plumbing in the house. And in a lot of instances, you might not even find the lead in your tap water and still have a lead service line going to your house. So here's a trick of the trade that I learned from someone some time ago. If you have access to the water inlet in your house, you go find that water inlet, take a quarter and just scratch the surface of your pipe that's going into the house through the foundation or through the concrete slab. Just scratch it with a quarter. If you see a bright, shiny, silvery metal, there's a good chance that you've got a lead service line going in the house, because copper obviously will not do that. Copper has a different color, and if it's galvanized steel, for instance, it's not going to be that shiny. So just scratch the surface and you see this nice shiny metal, then there's a good chance you have a lead service line going in the house.
What is the life of PET relative to other options like copper or plastic?
So comparable to plastic, it's very comparable to other types of plastic. PET has a very long life. It takes centuries to degrade when it's exposed to the elements. Here, it's not exposed to the elements. It's within the existing lead pipe. The good thing about lead, one of the good things about lead is that lead is very durable. It does not degrade over time. So there you have it, basically a brand new pipe inside your lead wall that will protect that pipe forever. So the longevity of a PET standalone pipe by itself is well over 50 years, and it's comparable to other pipe materials. Of course, copper is ideal. Copper will not degrade over time. It's extremely durable over time. It will last you centuries. Copper is expensive though, and if you're putting in a brand new copper pipe in your service line, then you're going to have to use, more heavy construction methods, because you can't just pull a copper pipe through the house.
And are there any issues with BPA leaching from the PET?
No, there's no problems with BPA leaching. And an important fact that I didn't mention, I think, is that obviously the materials, the PET materials that we're using is certified for drinking water standard. So all of the methods that we use and all the different materials that we use have been certified by NSF to standard 61. And that is very important, because that is the insurance policy that we give our clients as far as drinking water compatibility of the materials. So no, there's no BPA leaching from PET.
Yeah, and a couple other kind of broader questions here that we can end on. If you have any last questions, feel free to shoot them over now. Someone is curious about the perspective and need from Canada. How significant is the lead service line problem in Canada, and is there a movement to address the issue?
So yes, there is a lead service line problem in Canada. Obviously, it's not as extensive as it is in the US. Canada, the large cities all have lead service lines. Anywhere, anytime you've had construction in that era, you're going to have some lead service lines. We're seeing some very aggressive programs from the large cities, and I'll just mention City of Montreal and the City of Toronto in Canada have extensive programs to replace lead service lines, very aggressive, spending hundreds of millions of dollars every year to replace lead service lines. So for instance, as an example, us as a contractor in the City of Montreal alone will be replacing anywhere between 3,000 to 4,000 lead service lines a year. And it's pretty much the same thing in the City of Toronto as well. So the money's being injected. There's a program in place to replace lead service lines. But in large cities, I think at some point the City of Montreal was mentioning that they had somewhere in the range, when they started off the program, somewhere in the range of 60 or 65,000 lead service lines. They're well into the program of replacing all of those right now.
Thank you. And last question, I'll have Ben take a crack at it first, and then Tim, I'd like to hear your thoughts. This person wants to get some perspective on the lead service line inventory problem. How do we approach creating inventories that will drive replacement? And how do we know where to replace? How do we efficiently deploy funding and not waste it where remediation is actually needed? Ben?
Wow. I wish I had a very, very simple answer to that one. It's the big problem is, where are those lead service lines? So we know, and you mentioned, Sam, it's anywhere between 6 to 10 million, could very well be 15 million, who knows? It's an estimation. We don't know where they are. What's very encouraging is that the revised rule will impose on utilities to find out where those lead service lines are, which is a good thing, because then you can address the problem. I mean, to know exactly where they are, a lot of utilities don't have records of what was installed back in the day, and that's what creating the problem.
I think I would just add to that, Samantha, that I really hope that the Cleveland Alliance's program is successful, and you all can find the next latest, greatest technology that can help water systems find those lead lines.
Yeah, I think it was you, Ben, who said it earlier, is that, you don't want to be the last person to receive,
Right.
that replacement. And what we see over and over again, oftentimes the last person or the last places are the most marginalized folks who are affected by lead, who are affected by pollutants, who are affected by and need advocates, to come in and assist with how they're affected by environmental justice. So this is an issue that spreads far beyond, utilities and simple line replacements. These are real people in their houses who are affected by this every day. And I think thank you, Ben and Tim, for bringing both of your expertise here. I think we had one more question come in for Tim. I'm unclear on where state or federal legislation stands on the private property versus public ROW replacement. If still unresolved, is there any hope that federal legislation can help this?
Good question, and that's just unknown right now. It's still up for debate. We went from there was going to be absolutely no partial lead service line replacements to that didn't end up in the final rule that way. So it's still very much a point up for debate. And at this point, I have seen some legislation that is calling for no partial lead service line replacement. So there are members of Congress who are aware of it, and they are putting it in legislation. It's just a matter of will it survive in the sausage grinding of legislation in Washington.
Mm-hmm. Absolutely. Absolutely. So, obviously, as we've learned today, this is an enormous challenge, and water systems should have every certified and safe tool in their toolbox available to use to improve the infrastructure. So thank you, Ben Côté from Sanexen Water and Tim Cansler from Cansler Consulting for providing your insights. If Ben and Tim, if you wouldn't mind, we still have quite a few folks tuned in. If folks want to learn more about your product or service, Tim, you have your consulting services. You're clearly an expert on what's going on here. If folks want to reach you, if you wouldn't mind putting in the chat how folks can contact you. And Ben, if folks want to learn more about this technology, the best way for them to reach out and find out about that, go ahead and put that in the chat and select panelists and attendees when you answer. And I want to make sure that I just share a couple more slides about our next upcoming webinar here. Let me make sure I share my screen really quick. Thank you. Thank you. Yeah, lots of good feedback coming in. Thank you everyone for tuning in. So our, again, this webinar was presented by Cleveland Water Alliance and ALTRA Solutions. And at Cleveland Water Alliance, our next upcoming webinar is our Water Data Forum in partnership with the Water Environment Federation and the Midwest Big Data Hub. So if you found this conversation helpful, you might be interested in this one as well. This is about remote sensing for water quality. And that's going to be this coming Tuesday, June 29th from 2 to 3 p.m. Eastern time. Thank you again to our panelists. Thank you everyone for tuning in. And we'll make sure to send out this recording and send out follow-up information about how to reach Ben or Tim about their areas of expertise. And we'll reach out about our next webinar. So on behalf of Cleveland Water Alliance, thank you so much everyone for tuning in. Thank you.